Hello, class. We're on page 511, question number 9. The question reads as follows. What is the color of visible light of the lowest frequencies and of the highest frequencies? So let's look at that. So we'll go ahead and draw a little graph here. And we'll say that this is 0. And let's say that this is on the, how you doing it today? On the nanometer scale. So each unit in here is nanometers. This is about 400 nanometers. And then we can go out to about 700 nanometers. Light we can see is, just going to go ahead and draw a little spectrum. Looks something like this. And so now the lowest, and let me read the question again because I've forgotten it already. What is the color of visible light of the lowest frequencies? So when we think about the lowest frequencies, we're actually thinking about how much this light is actually vibrating, how quickly is it repeating itself in a given second. How you doing, Nick? And so what is that saying? Well, that's essentially saying if this is a time scale, then that's seconds. And this is a amplitude, or intensity, negative amplitude. We'll look at how many times this light actually oscillates in a given second. So in this particular case, the frequency is 2 hertz because it repeats itself. It starts here, starts at the origin, and at this point, it actually repeats itself. So that's 1 time. And we can do that again, 2 times. So that is 2 hertz. All right. So we want to know at this point, and this is what we can see. We are thinking about visible light, so we're thinking about what we could actually see. So we can see between a range of 400 nanometers and 700 nanometers. Below 400 is ultraviolet radiation, okay? It's what our skin, what the pigment in our skin, or what our skin uses to make, vitamin D. We actually need UV light. It does something to the vitamins in our blood. And then you have 700 nanometers. Beyond 700 nanometers, we have the infrared. Now, outside of this visible spectrum, basically the light is invisible, okay? So, if you have a fire, if you light a fire and you're sitting by a campfire, the light that's given off of that is infrared, all right? You can see other light, you see visible light, but infrared comes from that. So, the higher the frequency, the more the light oscillates, the higher energy it actually has. So ultraviolet light actually has higher energy than infrared light. And infrared light is, let's just do that. So this has high energy. And this has low energy. Energy. And whichever one has the highest energy, that's the one that's going to have the highest frequency. So 400 nanometers actually has the highest frequency in this particular visible spectrum. 700 nanometers has the lowest frequency. There's an equation that corresponds to that, and that equation is energy is equal to Planck's constant times the frequency. So you see that the energy is directly proportional to the frequency. So the higher the frequency, the higher the energy. The higher the energy, the higher the frequency. And we have this proportionality constant here, and that's Planck's constant. You know what? I do wish that I could connect this in a way. We have frequency that would be here. energy that could be, how you doing, Bill? Here or